basically, we got awarded the SMCP plant from ThyssenKrupp, which is a semi-mobile crushing plant, which entails quite a lot of intensive plate work, as well as structural steel and some cladding. And I think that's about just a brief introduction on it.
Okay, great.
Could I
Go for it,
ask
Spencer.
at this point in time, what makes for a semi-mobile crushing plant as against a mobile crushing plant?
Okay, so the design, I don't, Jens, do you want to take that one on the design point of view? Oh,
okay,
muted.
sorry.
Oh,
yeah,
there we
I've
go.
got too many buttons to press here. Sorry, good morning. Just to introduce myself, I'm Jens Dombrovski. I was the project manager on this job for ThyssenKrupp. Semi-mobile crushing unit. This crushing unit that we supplied weighs 1,500 tons and is used for crushing some materials in an open pit. So as the pit obviously grows, this unit has to be moved around, we guess every 1.5 to 2 years. But because of the weight and the structure, obviously you cannot put it on a truck or a low bed and wheels. So it is designed to be moved with specialized crawlers in a couple of sections. So that's why the semi-mobile.
Thank
it
you.
is a structure that stands on the ground. It doesn't have any wheels or so it is kind of permanent, but can be moved with specialized equipment.
Thank you.
Great. So my next question is, what were some of the challenges on this project and how did you overcome them? Francois, you want to start off with that? And then if you want to hand off to anyone, then that's fine.
So some of the challenges on the project that we started off, I won't say major challenges, was the design change to full penetration welds. So there was quite an intensive, sorry, are you there, Denise? Sorry, I went off.
Yes, that's just
Yeah,
okay.
I'm here.
Okay, so yeah, so the design requirement called for quite a lot of full penetration. So it was challenging to move all the plate work from our one shop to the other shop, where we're quite rigged up with all the nibblers and all of that to get the structures or the plate work going.
I think maybe what Francois was trying to say is that given the very difficult, or maybe Jens, with the what's what we're looking for the requirements, the process requirements of the piece of equipment for a semi-mobile crushing plant, it obviously gets a proper beating. Obviously, as the rocks fall on it, and it needs to be manufactured to a very high level of quality. And so ThyssenKrupp obviously put that into account when they designed the equipment. And so in order to accomplish that, we had to adhere to very stringent design requirements and fabrication requirements when manufacturing this piece of equipment. One of the challenges being all welds needed to be full penetration welds, which comes with its challenges in terms of manufacturing heavy plate work and non-destructive testing with ultrasonic testing, X-ray requirements, etc. So that was probably one of the biggest challenges for the project. That being said, one of the other challenges was the tandem lifts, being that some of the sections weighed up to 56 tons and were manufactured in one piece. So that was quite a challenge with the manufacturer as well.
Nicolette, that does kind of roll into the next question. Can you expand a little bit on the fabrication process and the actual erection process or placement of the project on site?
Sure. So obviously we can speak quite in depth about the fabrication process. I think Jens would be better suited maybe to speak about the installation on site. But from our side, for the fabrication, in order to achieve the best quality welds, we blasted all the plates prior to assembly, so that all the mill scale and slag was taken off the plates, so that when we welded, we got excellent quality welds with very minimum defects. And obviously then we assembled at our workshop in Krugersdorp, and we used various welding processes to achieve those high quality welds with the pulse arc technology welding machines from Europe, to basically minimize the heat input and distortion that were achieved with the welding of all the very, very thick plates. I think the thickest plates that we had, Mark, maybe you can help me there. What we obviously, most of the plates was 12 to 25 millimeter in thickness that we were welding on all the sections, and obviously some of the very, very thick plates went up to 40 and 50 millimeter plates that we used on the fabrication.
How would you say that this project demonstrates the benefits of steel as a material?
So I think it would have been very difficult to fabricate a piece of equipment like this in any other material than steel. And it shows the versatility of steel, that how steel can be used to fabricate such industrial equipment. In
your project support document, you talk about laser alignment. What was that used for?
So I've got our production manager here, Mark, as well, that he can maybe comment a bit more in detail in terms of the laser alignment. But my understanding obviously was that because of the exacting requirements of the plant, the alignment of the assemblies was extremely critical. Obviously, this was a bolted construction, partially bolted construction design from ThyssenKrupp, and when it needed to be installed on site, obviously the parts had to align perfectly. As you know, you can't bend a bolt by 2 millimeters. If the bolt holes don't line up, then they're not very bendy. So you basically, everything had to slot in perfectly. So all the parts were laser aligned, so that when they were assembled on site, that assembly was seamless, and then there was no cutting and modifications that were required. Am I right, Mark?
Yeah.
Wait.
Sorry.
Can you still see more? I'm dropping. There's more.
Hi, good morning, everyone. Yeah, for the laser alignment on the pontoon side, the bases, that was extremely critical, especially when you go up with this the whole structure. You get to the dusted at the top. If you are up with quite a few millimeters at the bottom, going up at 10 meters or so, 15 meters, it's very important to have these bases properly aligned at the bottom. And to achieve this, we had to use the laser alignment on the bases, because the boxes on some of the pictures that we went past for that 50 tonners, the boxes that we had to attach on the sides and everything after welding, it was very important for us to achieve these dimensions to be within the 3 or 4 millimeter that we actually achieved on our red line drawings afterwards. So that is very critical for us to use these alignment methods.
Thank you. Were any of your flanged interfaces machined?
On the flanged interfaces that we had on the pontoon at the bottom, it was only an access hole that we had there. And if I remember correctly, these were about 800 millimeters in diameter. So this was just access holes to close it up again. But the mating faces, we've got 3D bevel technology on one of our machines. So we get a fairly good, straight and accurate surface after beveling or after plasma cutting. So there was no machine requirements from our side on that part.
Thank you.
Any other questions, judges?
Just one more. How much touch-up painting is required once it's erected?
So in theory, it depends on how it is handled on site, obviously. So if care is taken when handling the goods, and there were specified lifting points, lifting lugs that were obviously designed for that function, then minimal touch-up painting would be required. In terms of, it would only be whatever was created due to handling damage.
Right, any other questions, Spencer?
I understand they don't want to mention the client, but it looks very much like coal handling to me. in which case it's going to be covered in coal dust forever, which is a very good corrosion protection.
Yes.
So what would you say is the most technically impressive part of this project, Nicolette?
I think we do have the model, obviously, of the whole plant. I don't know, Denise, if we want to show that at the end, or if you want to.
Yeah, sure. You're welcome to. You're welcome to do so if you want to share now. I don't have very many other questions unless the judges have got more questions that they'd like to ask. So.
Okay. Okay, I think Francois is going to share his screen now for the Tekla model that was done.
Okay.
Nicolette, also just one other question. Were there any complications during shipping? I assume this was all on overland, right?
Yes. So not to my knowledge. Maybe Jens can comment on that, but I think they did a fairly detailed route survey. Can you see Francois' screen?
Yeah.
Mm-hmm.
Okay.
Yeah, I can confirm we didn't experience any problems with the transport of these units.
How do I zoom? I've got to click. So this is the Tekla model. Obviously, I think it was shown that Betterect, the design obviously came from ThyssenKrupp, and Betterect did all the detailing in Tekla for the project. And maybe just to give you an idea of scale, the previous pictures that Denise put on the screen that you saw of those items that were on the truck are all these little purple guys at the bottom here. So I think that gives you an idea of just the magnitude of the size of this plant. So, and in terms of the laser alignment, obviously the base pontoon, as Mark was mentioning, went in the sections that you can see. So obviously, 25mm plate, 30mm plate is very unforgiving if your box is not 100% level, 100% square. And as we know, when you put heat into steel, it distorts. So the construction fabrication methodology was extremely critical in terms of how we fabricated those items to ensure that distortion was kept to a minimum. And that was where we used the pulse arc welding technology to minimize that heat put into the steel to minimize distortion wherever possible. And that was what achieved the very high tolerances as well in terms of when that item was assembled on site to give you that, well, I'm trying to figure out how to spin this thing. There we go. In terms of the mating interfaces that they fit together so well. So there at the bottom in purple was the pontoon. What we see here is the grizzly chute that was fabricated by Betterect, and all the liner plates were fitted to that, all the VRN 400 liners. Again, mating interfaces everywhere that you can see, that they all needed to line up perfectly together. The platform, and then right on top, obviously, there was the dust hood building that was the right on top of the structure. So that's the critical nature of just the scale of the plant that had to be fabricated and everything had to fit was very, very important. Shout if there's something specific you want to see.
Can I ask another question, please? Lizette, you've mentioned pulsed arc welding a couple of times. That's sophisticated mag welding, is that correct?
Yes.
Thank you.
So basically what it does is it's, Mark can speak a little bit better because he's probably more up to speed with the technology, but obviously it modifies, instead of having a normal arc, as would be with the standard welding machine, there's been quite a lot of R&D and into the actual pulsing of it. And by pulsing the arc on the welding machine, you can actually penetrate further and limit the amount of heat that is put into the plate.
Any other questions? Judges, Emmanuel, any questions? Franco?
Just from my side, geez, logistically must have been a hell of a challenge. And how much in total did we say the mass is of the structure?
So I think
roughly 1,500 tons.
That's that
But
logistically.
that obviously includes some of mechanical equipment, not just the steel structure. The steel structure itself is about 900.
This is heavy engineering at its best, eh?
Yes.
Right. Any other questions, judges?
Has it been assembled yet?
Well, we started assembling it beginning of March, and then
They got quite
unfortunately,
far. Yeah.
end of March with the lockdown, the site also closed in Mozambique, and it hasn't reopened yet.
Okay.
So we basically just started.
But we did,
some of the basements.
for example, the pontoon, we did quite a lot of trial assembly in our workshop to ensure that everything fit together. And obviously this, can you see my mouse? I'm not sure.
Yes.
This grizzly, is it the grizzly or the chute? I think the feed hopper, there we go. That was also fully assembled. So all the critical mating interfaces were assembled to ensure that there would be no clashes on site, or how would you like to say it, any issues on site. There we go.
So what would you say you're most proud of on this project?
Sorry, say again, Denise, I lost you there.
What are you most proud of on this project?
I think the quality of welding was really a flagship project for us to showcase our capabilities in terms of the full penetration welding capabilities that we've developed over the last 40 years. And I think just the scale of the project and the size of the items, and that they fit so well together when they started putting the items together on site.
Right. Anyone else want to comment on that? What do you think is most technically impressive? What you're most proud of, Jens?
Well, from my point of view, we had a very, very tight time schedule.
Yes,
and,
that's actually a good one.
Betterect managed to actually achieve what they set out from the beginning. So yeah, well done to Betterect on that from our side.
Yeah. But maybe if I can add to that, just what Jens is saying is that, as he mentioned, the project was under a very tight schedule. And obviously, as we manufactured the steelwork, there was, in parallel to that, there was also the designs on the electrical side, the ground pressure design, the maintenance and operation access design. All of those things happened in parallel. And I think a lot of it influenced a lot of the steel work. And on short notice, Betterect also managed to modify some of the components to cater for these designs in the end. So that was well done from their side.
Right.
And maybe just a comment on the schedule, and feel free, Jens, Wilfred, to correct me if I'm wrong on this the statement. But the total timeline of the project was approximately, from the start of detailing to completion, approximately about 12 to 16 weeks. So obviously we started detailing and then we started fabricating quite soon. So the bulk of the fabrication of that 900 tons was actually undertaken in a period of about 8 weeks. With the overlap of the detailing and sort of corrosion assembly. So I think that for us was extremely a proud moment that we could fabricate that amount of steel in such a short period of time.
Great. Judges, any final comments or questions before we close?
Just one thing, was there any problem getting hold of material from merchants or wherever you got it from?
No, not at the end of last year. Fortunately, we obviously keep quite a bit of material stock, but even that, so the material was readily available from the merchants. Not so much at the moment,